Today's topic for the webinar is Arbonaut Forest Inventory. And we have two guest speakers here in the webinar. First, Mr. Vesa Leppanen, CTO from Arbonaut, will start presenting LiDAR inventory proves timber supply from thinnings. And after this 15-minute session, there will be a question and answer for 10 minutes. And his presentation will be followed up by Mikko Rantanen, who is the CEO for MMP. So without further talks, I would like to share the floor and give the floor to Vesa. So please go ahead. Thank you.
Thank you, Jarno. Can you hear my voice?
Yes, I can hear you very well.
Right, cool. So my name is Vesa Leppanen. I'm CTO of Arbonaut. And my background is that I've been 25 years in Arbonaut working with LiDAR metrics of timber and forest resources in all areas in the world where there's basically commercial forestry. And today we speak a bit about timber supply that could be available from thinnings. Thinnings have been done quite a bit in Scandinavian forestry, but a bit less in BC forestry. And it seems, based on what we have been looking there, that there's quite a bit of possibility or timber supply available if that would be used. So first we will peek a little bit into Scandinavia, where we look into the LiDAR measurement methods, a couple of minutes, and then we go and take an example of UBC research forest, which is about 5,000 hectare forest area near Vancouver. And we see what kind of timber supply would there be in this example area over there. So now I will share my screen. Can you see a map of Scandinavia?
Yes.
Seems like it's sharing. So here you can see Finland. Some of you visited here this fall. And this is Sweden and this is Norway, our friends out west. And BC is about, as a size-wise, Norway, Sweden, and Finland together are about same size as BC. And we'll be zooming here. This is way up north, and it's a timber property about 13,000 hectares, so not a very big area. I decided to look at this area because it has quite interesting project we did there using the modern LiDAR technology. So it's a good place to look a bit of this methodology. So here we are looking actually now hill-shaded terrain. So as you see, it's very flat area in this case. And this is the tree height model. So I was thinking to zoom into this area here that has some tall trees in it. So it's a bit more interesting in terms of looking the canopy. So this is now the canopy height model. So the red trees are about close to 20 meters high, and then green are in thinning age, and yellow are young stands. Gray is recently harvested. And I will just click on the tree diameter map. So this just shows how the LiDAR inventory is done. So we have polygonized all the tree crowns in the area using our automatic ArboLiDAR tools. And this has been done from the LiDAR data that's about 20 points per square meter. And this LiDAR data is spectral LiDAR, so it has actually 3 different laser bands in the sensor. That's, I think, the best in terms of measuring timber and forest resources. And here you can see the map now of all the crowns. So in the modeling end, we don't expect that there will be always one tree under each crown. So when you look at the forest, it's quite complex sometimes. You may have trees that, for example, a pine tree, and there might be a spruce tree growing under it, or a couple of them. So here I'm clicking one of these trees, and it shows that what's the measurement. So this measurement was done by putting about 150 plots in the area, circular plots where we measured the trees, species, diameter, some of the heights. and then the location of every tree. And this way we're able to match it to the LiDAR crowns here. And sometimes one crown found under it there was 2 or 3 trees, sometimes 1 tree. So in this case, what we can see that the tree height there was 17.8. Being so north, these trees are not growing very tall. Diameter 28, volume 0.7, and actually it says that there's 2 trees under it. This is how we can look at the trees. Now when we look at the trees, we can sum them up to stands and whatever geometry we want. So this is a volume map of the same trees, and here's the species map. So here the pine is showing purple, spruce is green, and deciduous are orange. And when we have these trees measured, then we can put stands on them. We can automatically create stands or use your old geometries if you have. And now we have summarized these 3 values into the stand. So you can see the stand summary here. And now we go, after this view, we will go to the UBC area, so we have some time to look at that. Can you see the UBC area?
Yes.
Okay, so this is the hill-shaded terrain of the area. We are looking at 1 to 100,000 scale here, and as I said, it's about 5,000 hectare piece of forest in British Columbia. So you can see it also on satellite image. From a satellite image, you can see that there's been some harvesting happening in the area, and there are some managed stands, and then some stands here on the mountains seem to be maybe more like a reserve. And I'm putting now tree heights on, so it's the same kind of map we saw in Sweden. So as you see, these trees are very tall here, and then in this valley area, there's this zone here having forests that have been harvested at some point, and new growth has been established there. And this end, the trees are a bit taller than. But let's look at the diameters a bit as well. So here we can see that biggest diameters also are on the mountain area and smaller ones in the valley here. And looking at the data, we can look a couple of diameters. So these big ones here, the diameter is pretty big. I can see 60, sometimes 75 centimeter trees here as diameter. So this forest and the mountains are pretty awesome looking trees. As we look at the species mix, this area is mostly conifer forest, but you can see some areas where there's some broadleaf trees. And now we go to the actual thinning business, because that's the topic of today. So basically what we have done for the whole area, we have made a grid of timber inventory here. So from the trees we put the values into the grid cells. They can make nice areas then to work on. And here this black grid covers the entire area, so every square meter of the land has been measured. And now I'm putting on the thinning index. So from that grid, I made a query asking at where would be the areas that would be interesting for thinning. And these areas I selected just putting some numbers that I pulled from my own sleeve. I think there's not so much science made yet in BC how to do thinnings and what would be the basal areas where you start thinning and what kind of diameters and height of the trees you would start thinning and how would you cut. But there's some, I believe, legislation that says that after thinning, if you do that kind of logging, the basal area must be 20 or more. So I use that as a cut ratio. I think we could later on discuss that is it a right amount for every stand, maybe not. If the stand is very high density, it might be, let's say if the basal area is 65, you might want to leave maybe 30 or something instead of 20. But here this is just, this value can be easily altered. So I looked at, also selected these ones by saying that the diameter of the trees needs to be between 16 centimeters and 38 centimeters. So I looked some of the areas that had been harvested here, and when it seems to go to 35, 40 centimeter diameter, it is final felling then. I saw some areas also that had been harvested at diameter of 30 some. So there is some area here, for example, these red areas where it's possible to do thinning or final felling on the area. I also put a limit that, okay, we don't do thinning unless the thinning yield is more than 100 cubic meters per hectare. So if you do a thinning and you don't get enough into your wood pile, you would not be happy with this financial result. So 100 cubic meters, I said in Finland, rule of thumb is that the commercially viable thinning is when you have 60 cubic meter yield. But I think we see machines being bigger, trees being bigger, and being a bit more slope and other factors, I just used that 100. And now this coloring here actually shows the thinning yield. So in some stands you can have pretty high yield when you do thinning. And this is thinning yield if you take the basal area you have there now and reduce it to that legal limit of 20. And then we looked at what percentage are you removing from the volume, total volume, and based on that we estimate how much volume you would get from the thinning. So let's go look one example stands. It's around here somewhere. I made a, I will zoom in with this bookmark. So here we are looking an area where we see it's green. It's around 100 some cubic meters if you do a thinning. Let's look some of the thematics on it as well. I'm putting on the tree height map. So you can see that this area here, you can see the big stuff on the mountain sides. And this area has been clearly harvested. There's a road going into this stand. And we can see that there's green growth. So the tree height is somewhere, if I info it. I think 16.5, the tallest trees here being 18. So it's a bit below 20. You get some spots where the trees are not so high, but mostly I would say around 18 meters height probably in this area. And the diameter map shows 25 here, 28. So there's already some diameter on this stand. And now I'll put on the thinning index value, and I will select these cells that are inside the stand. So here, and then we just draw a polygon. It's fairly easy to do selection here. I'm using QGIS. You could use ArcMap or whatever tool you like to do this kind of work. So here's our thinning outlined. As you can see, these yellow pixels are selected. And then I will just ask that, okay, how much area did I do? Okay, that's 22 hectares. So that's pretty much the size I've seen there being practiced. And if we did final felling, so total volume would be 9,000 cubic meters, but that's not the time yet. So let's do the thinning. So in thinning, we would get 5,436 cubic meters of timber. And if we ask what is the basal area here before thinning. So 49. So it's pretty high density. As far as finish conditions goes, it's very high basal area already. And you can take a bit more than half of the trees out in the thinning to be at the basal area of 20. So this way you can investigate and find where to do thinnings. You just set the query parameters right and query out, and then you make a thematic map, and there you go. You can get the thinning map of this 500 hectares. We could find all these reasonable thinning stands. If we work one day, we could outline and say, here's where what we can thin. And then if you want to look a bit on the yield, how much would you get if you did all these thinnings? So as you see, there's a little bit of salt and pepper. In this one, I did not use the national vegetation inventory polygons here. They could be used to sum up, but I thought I'll just summarize if we did all these cells. That gives a good idea of the yield. So we just do this. I unselect everything. We select this guy here and say how much area in this one. So in all these cells, out of the 5,000 hectares, came out 13,000 hectares altogether. It would be reduced a bit if we remove some of the areas that might go to final felling soon. So I use 38 centimeters on the top line. Might be a good reason to drop it a bit, 35, 34 or something, and say, okay, when the diameter is above that, we don't do thinning anymore. That would remove some of the red areas away, but this gives a reasonable order of magnitude. And then out of these, here is the value that lets you sum. So we could find 396,000 cubic meters of timber from this 5,000 hectare property. I just open this crap Excel here so we can do a quick calculation. So 395, 897, and we divide it by the 1,300 hectares. So as an average, you yield 304 cubic meters per hectare from this operation. So I would say that's pretty good. Probably when we do a little bit of more studies, we might end up saying that if the basal area is 60, you don't drop it to 20, it's too much. The trees might get a shock, light shock. So the quantity you can thin might need to be reduced a bit and saying, okay, we leave a bit more basal area if the basal area in the beginning is very high, so the trees don't get too much soaked in. So, okay, did I use my time? So thank you. That was a very brief intro into how to look at thinnings in BC. When BC collects LiDAR over the entire territory, I think this is a viable method to go and make a timber supply source that is financially, ecological, and economically reasonable. So thank you. Any questions? I'll be happy to answer.
Yes, please raise your hands if you have any questions. So let's take them one by one here. We have a few minutes time to answer. Seems that there no questions yet. Okay, now a couple of questions coming in. So maybe you start, Jorma. Welcome.
Just quickly, Vesa, well, thank you for the presentation, by the way. Did you do sample plots in Malcolm map? Did you have to do many sample plots in order to get all the sort of basic information of the stands?
There was actually, we got the sample plots made by UBC. So we used your sample plots. If I remember right, 250 to 300 plots. but that's what I was left with in my mind. I wasn't doing modeling, so don't remember that exact number.
All right. Okay. Thank you.
Yeah.
Thank you. And the next is Alan. Please go ahead.
Yeah, thanks. My question is very similar, I guess. Maybe I'll just ask it again in a slightly different way. I'm curious of how you got the diameters from the sample plots to the diameter distributions that you had.
Yeah, good question. So what we normally use is a circular plot, and you define the plot size so that you have, as an average, 20 trees per plot at least. And then we use a GPS plot where the plot center location is measured, and then the distance and bearing to every tree. There's tools to do it, so you can just carry the tool, and as you use the caliper to measure the tree diameter, attribute the species, it will also record the location. And then these plots you sample so that if you have preliminary information, you sample so that you get all 8 site classes and species covered. And then when we start doing the modeling, these plots are fit to the LiDAR crowns, where we have detected the LiDAR, trees from LiDAR. And then actually we can use many methods, but one method to do is to do just imputing. So you just find the most similar guy among your plot polygons for each tree you find here in the data and attribute those trees there. So that's been used. And then there's some more complicated models made also sometimes how to do the prediction. So that prediction business is world of itself, but we've been doing it for 25 years. So that's typically works all right. There was another.
Thank you. Yeah, there's one more, Zeka. Go ahead.
I was muted. Vesa, thank you for the presentation. Great presentation. I'm just curious, in your Sweden model, you showed us species for the working area that you were presenting. I was just curious, did you outline the species using LiDAR, or there is an inventory layer that you used for that? How did you come up with the species?
Yeah, we used LiDAR because we indicated 3 species on every tree on the plots. And then we used spectral LiDAR, which means that they have a laser beam in the LiDAR that's on infrared band, another infrared band, and green band. So it tells about the reflection on these 3 bands, and that helps you to define the species quite nicely. So
with the LiDAR. With the LiDAR bands, right?
With the LiDAR alone, yes. If it's a single band LiDAR that's most commonly used, then you need to have photos to do it.
Okay, all right. Okay, thank you, Vesa.
Thank you.
Thank you very, very much for the good questions. So I think if no questions at the moment, I think that we can also move ahead, unless you want to say anything, Vesa, from your side at the moment.
Yeah, that's cool. If some questions come up, maybe in the end, there may be time, depending how many.
Let's spare some time for the end. All right.
Yeah.
All right. So I would like to let's say present the next presenter. He's Mikko Rantanen, CEO from MMP, and he will actually demonstrate Arbonaut maps in John Deere Timber Manager and Maps. So the floor is yours. Thank you.
Okay, thanks. Hello, guys. Just let me put this sharing on. Yeah, so this is, well, about myself. My name is Mikko Rantanen, and I'm running my own company. We have about 15 guys doing basically the cutting planning in forest. But before we go to the forest, we use these new maps that are now integrated in this John Deere Timber Manager software. And I have one actual site that our guys were planning this autumn, and it was actually the cutting was supposed to start today, so that we could have even seen the machines going in there, but there was some delays, so that didn't happen. But this is still actual site, so you can see it's a thinning site. So there's 3 different areas, and this is the view that we used to have. Very basic map, but now that we have this hillshade, it opens up a little bit, so it's much easier to see the shapes of the hills, and we can see that here has been some pretty interesting work. They have been digging some kind of ditches up into the hills even, but so it's you can see it's on the swampy areas, so it's wet place, so it will be, that's why it's cut during the winter, and we can see the depth of the ditches here. So the darker blue it is, the bigger it is the ditch, or wider. So we can see that there are some places that are not very easy to get over with the machine. But anyway, we start here. First we draw our site here. So let's do that. So we just so this is like the map that the forest company and the forest owner has made the deal with, and we first, that's kind of our main tool. So yeah, so that's the first area, so it's 6.7 hectares. Let's approve that one, and we put it's a cutting area border. Save, and then we can draw another one. Let's draw these all like this, so it's pretty easy to just click around like this. So it's 4.3 hectares. This is pretty normal sizes, even on the bigger side, let's say. So it's actually company-owned forest, like that. And this small area also, let's draw that also. Like that, so it's not even half a hectare. Okay, now we have our borders, and this is actually the tool that, oh no, it's wrong, tool that we use every day, and we manage about 2.2 million cubics per year, so it's we use this quite a lot. Okay, so now we have our basics are here. Now we can remove this layer and take a look how it really looks the ground and the forest. So as I said, there are those ditches and there's pretty steep hills. Well, at least in the Finnish way, I believe you have much bigger hillsides there, but this is already big for us. And then we can take a look of the wetness index. So let's open up that layer. Of course, it's slow every time you present it. Okay, so it's not terribly wet. So this really dark blue here, it's probably much more wet than this. But still, anyway, this is something that we will do during the winter because of the swampy areas. And this also, it's completely on the swamp, basically, but it doesn't look too bad. But so it's pretty okay. And then we can look at the yield, that how much are we going to get out of it. So the thinning yield. So I put this one on. So when it's dark red, it's more than 100 cubics per hectare, and then 80, 60, 40, and so on. So mostly it looks pretty decent. There's like a really empty area up here, so it's probably smaller size trees. There it's probably more wet area, and the trees haven't grown so well. And here also, for some reason, there is not so much, but here in the main area, it looks pretty decent. Basically, like 60 to 100 cubics per hectare. And here also, it looks okay, a bit less, but here it's a dark red areas, so it's looks pretty basic and okay. And then we can take a look at the tree species. Yeah, so blue is pine, green is spruce, and yellow is broadleaf trees. So it's mainly pine here, and here it's a bit spruce on the side and broadleaf trees. Here this bush over there, and here this looks pretty funny. It's a spruce on the sides, and in the middle it's mostly pine. And this is mostly pine, this small area. So now we have pretty good idea what kind of forest we are expecting to see. And then the height of the trees. Vesa showed you already this. So it's not too tall. It's about maybe this. Well, the red areas are like 20 meters. Some might be even more, but let's say from 16 to 24 meters roughly. So now we can kind of fine tune this map, because now I can clearly see that this forest continues here very similarly, and then we can just change our border a little bit. So I'll just do it like this, like that, and so now we have 7 hectares. So it's reasonable to cut also that area and not to left it behind. Let's put it all the way to the red ones are property borders. So that's our limiting factor. Definitely we can't go on the neighbor's side. Okay, so we changed it a little bit like that. And let's see the other, yeah, maybe here we change it also a little bit. It goes here in the bigger forest. So this dark red area, it's probably gonna go for clear cut rather than thinning. So we save it outside like that. And here also we change this to go next to the ditch, so that it's just a clever, better idea to put it that way, I would say. And let's fix that over there. Yep, like that. So now our borders are better. Okay, that I'm gonna fix still, just to make it look better, like that. And so now we know what we are going to cut. Oh, let's see, there's this hillside that looks maybe a bit too difficult. So when there is this, when there's this yellow tint on this hill, it indicates that it's too steep for the forest machine to go. So anyway, well, of course they don't go if they can't go, but I'll just, for example, I will change it a little bit like that. Now this yellow area is out, and that we can do it also like that. Yeah. So that's good. And so how do we get there? So the road here is this one is road, you probably guessed. And now we need to figure out where to get the landing site and so on. So we have this landing possibility layer. So if it shows green, it's okay, and if it's orange, then it's too steep on the side of the road. So the other side of, as you can see, there is a pretty steep hill right next to the road, so it's impossible to put any piles on this side of the road. But this side is okay. But then again, there is also the profile of the road here. So if it's yellow, it's okay, but when it goes to pink and darker, then it's too steep for the truck to stop. So let's put the landing site like here. And yeah. Oh yeah, I'm using the wrong tools. But yeah, you get the idea. I can't find a landing site there. It's in different place. But anyway, here is good place for landing, and here also. And so now next we need to figure out how to get from the road into the forest. And there it's good to just shuffle around some layers to see if there is some natural roads through the forest. So this is pretty young. It's only like this, let's say 6 to 10 meters tall forest. So it's young forest, and it really sucks to go through that. So and as you can see, it's pretty dense. There isn't any natural clear areas where to get through. So it's basically just you need to go it like from here. This is my first idea. So that's our way to get into the forest probably. Let's put it yeah, main road like that, and then yeah, and this one is almost next to the road, so this is much easier. You just take the shortest way. I'm not even drawing the line. The operators can figure it out themselves. But then how to get into this smaller area? Yeah, it's pretty obvious that you just go on the side of the young forest, like from here, you drive the machines to the smaller area. Like that. So now we can reach all the areas. And yeah, that's pretty much it. I can show you the actual photos from the forest also. So this swampy area that it was pine in the middle and more spruce on the sides, it actually looks like this is from the middle. So it's a pine forest, and there is some birch mixed. And the next one, it's a mostly pine, and there is some spruce, also a little bit birch. So the indication that it's mostly pine, it's pretty accurate. And some other photos. Oh yeah, there is this retention trees. Yeah, that we can go through. So the forest certification demands us to leave some retention trees. So we also need to figure out what's the best place to leave them. And this hill here, it looked a little bit steep. Yeah, on this side of the hill, it's yellow and orange. So it's I would say that we would leave the retention trees. There need to be 20 trees per hectare. So this was 7 hectares. So it should be enough that we leave here kind of, yeah, we put it like roughly like this. And then we put it a natural reservation area like that. So now that we have done this, then we go into the forest and just see if the plan works. And there might be some new ideas in the forest and some little changes, but this is really good way to get the first-hand idea what to expect in the forest. So the work in the forest is actually pretty fast and efficient at the moment because of these maps. You don't really need to walk around the whole area. You can just take a look the most interesting areas. There's tons of all kind of natural conservation stuff that we need to take a look in the forest, so we can really determine already from the map that what are those places that we really need to take a look. So it's a great tool, and it's actually working. So it's we use this every day, and it really helps our work. So do you have any questions?
Yeah, please go ahead with the questions for. Okay, Alan.
Yeah, thanks for that. And you actually answered my question partially there in your last piece about field verifying what you lay out in the office there. So I'll change my question a bit then. If you field verified, is there any call for hanging of ribbon in there to define the boundaries, or is the operator just given this map once verified?
Yeah, it's the operator gets the map. We can send the map directly from the timber manager if it's a John Deere machines that are doing the cutting, so we can just send it directly from here. But there is we don't need to get any other permissions anymore, unless
or marking or sorry marking.
Yeah, the marking. Yeah. Sometimes we do the marking, especially the property borders. We need to mark. So, but if it's not obvious, so there is definitely some marking, and these conservation areas we need to mark. But mostly, well, I can say that on this place only the property border was marked, and everything else is on this system.
Thank you.
And Sega, you please go ahead.
Okay, thanks for the presentation as well. I was just wondering what platform do you use here and for the mapping and the data sharing and maps sharing, and what level of information management comfort your contractors or whoever goes on the field to use those maps they have to utilize them. Like, are they how easy is this to send to somebody who is going to come in that area with a machine and do the work? Would they be able to receive this properly and utilize it in the field properly?
Yeah, we have pretty good cell coverage all around Finland. So basically, well, this place is in southern Finland, and here especially we have really good coverage. So the machine just they drive it into their place and they open the computer and they just download the map. They don't even need to download it; it just pops up for them. And so it's pretty easy, at least in Finland, to operate with the maps because we have the coverage everywhere.
So, Mikko, what platform do you use to share the maps that way, as you just described?
Yeah, all the maps, the whole Finland, it's in this Timber Manager. So you just sign into this, and if you have the rights, then you just see all these maps that I have shown you. So I don't need to share the maps. So they are just there in the system, and basically everyone who has the rights can see them.
Okay, so they actually log into the application itself, and then they utilize the map. You don't share them online like something that we have with the web maps or so on, right?
Yeah.
And the application is John Deere Timber Manager.
Yeah, and the exact same map system is in the machines also. It's Timber-matic maps in the John Deere machines. So they get the machines, and if it's some other like Ponce or some other machine, then we can send these maps from this company portal. So it's not really any problem here. It's pretty straightforward with the maps.
What I'm hearing from you, Mikko, that you all use the same platform across the board, like from your company to the contractors to everybody else. You all use the same platform for communication on the maps and data.
Well, not exactly the same maps, but well, that's one problem that some companies, they have systems that don't talk to each other. So there is some hiccups with sending some data from one company to another, but it's getting better. But basically, it's pretty easy to send this map information from operator to another.
Okay, thank you, Mikko.
Yeah, sure.
So any further questions to Vesa or Mikko? Is there anything, Mikko, you would like to show still? We have few minutes, maybe.
Let's see. Yeah, well, one thing that I'm not sure if it's interesting for you, but we have this visibility in the forest. It's something that it's sometimes problematic. So we need to do clearing before the cutting. And here, especially the south part of this biggest figure, there is a kind of, it looks very bushy. So it's visibility on the 1.3 meter height, the horizontal visibility. So here it's a pretty green, it looks. So it's a, let's say it's the visibility, it's 20 meters to 10 meters, something like that. So it might be that the south part here needs clearing before cutting. So it's like, I don't know if it's something that you usually do. I have no idea.
All right. We have a question from John.
Yeah, what slopes would you kind of use to use as your cutoffs where it's not going to be operable?
Yeah, I don't remember the actual parameters here. Do you, Vesa, remember what's?
Yeah, so I think 1 second. I have this slope map here. So it's second forward mobility. So we use 15 to 20 degrees. So less than 15 is operable with like a fully loaded timber forwarder. 15 to 20 we put as you can drive uphill or downhill, and then over 20 is non-operable. That's been used mostly in Scandinavia. So this kind of fully loaded forwarder, it's a 6 or 8 wheel forwarder, and it has chains on both ends. So quite capable moving in slopes. But those kind of values we normally use here.
Yeah, awesome. Thank you.
But that's something you can define depending on your equipment. So if you have different mobility, so mobility is, can be different on different seasons, and it can be a bit different on different operators, and depending on your chains and equipment. So it is possible to produce exactly to your slope limit.
Thanks for that.
I don't know, Vesa, if you want to explain a little bit further on those like wetness conditions or like.
Yeah, so because we need to make the wetness map is made to be stationary, or we don't change currently in these maps the wetness value based on weather. It's not dynamic, so then it means that you have to read it in a way that this area is kind of accumulating water when it comes from the sky, and the more blue you have, the more probably it's wet at your season. So normally areas that are showing clearly blue here, they are winter harvest. They are typically organic soils already. So when you get enough water on the soil, it means that the groundwater is close to the surface, and then the decomposition of the litter is slow enough that it develops organic soil. And here you can see that this light blue, they can be often operated in dry summer conditions, but then the darker blue is definitely frozen ground only. But that depends. Always the weather's change, and different different equipment, so they may have slightly different mobility. Also, we have made some maps of the seasonal harvestability. So there we also look how, if it's a peatland or wetland, how deep are the ditches and how much timber is on it. So if you have 100 cubic meters of timber on it, the root mass is also carrying quite a bit. And that allows you to harvest maybe in dry summer condition. But that's how we look at the, about 1/3 of Finland is wetland. So it's quite critical that we define that mobility right. The slope map, as you see here, it is actually pretty cool to use in a way that if you have, for example, a shelf over there where surrounded by steep slopes, you just look at the smallest gap in that slope where you find a green path or a gray path, and that's how the operators can get there. So it's been proven quite a few times that the operators just look at this map and see, okay, there's a little narrow stretch there that I can reach and go through, and they truly drive it.
Thank you. All right, so I think that we have explored all the questions, and thank you for the presenters so far. So at the end, I would like to give a floor to Jukka for the closing remarks here. And thank you very much for your questions and participation.
Thank you. Can you hear me?
Yes, go ahead.
Okay, thank you. Thank you to Vesa and Mikko for very informative presentations. So my name is Jukka Matikainen. I'm the brand ambassador of Forest Joensuu here in BC. And as Jarno mentioned, I'm going to say a few closing notes here. So first of all, this inventory data topic is very timely at the moment. As BC announced a $38 million investment in the LiDAR data last year. And that investment will be made over the next 6 years, if I recall correctly. So based on my understanding, there is some work going on already on this front, but there is lots of work ahead. I learned very recently that there are lots of things that can go wrong and ruin the data accuracy. Apparently, the plane that collects the data needs to have 2 motors instead of 1. Otherwise, the vibration is too high and ruins the data accuracy and those kind of things. So I'm sure that Vesa from Arbonaut and his colleagues can assist and give advice to ensure success in the data collection process and the further steps if needed. So feel free to reach out to Vesa if any assistance is needed there. So as most of you already know, Joensuu and great. So as most of you already know, Joensuu and QNL have a memorandum of understanding. We have planned a series of activities for the coming months and years. From the inventory data perspective, it would be awesome to see QNL being a testing ground and showcase for the rest of BC. Naturally, this testing ground could be also elsewhere. So feel free to reach out to us if you are interested in discussing about that more in detail. And if you are keen on pursuing this idea, and have some connections, we are happy to be involved in this conversation. So since the Canadian delegation visited Finland last year, we have had lots of good momentum going on and interest in Finnish solutions. So if you are interested in hearing more and learning more about those technologies and innovations from Finland, we are going to arrange many events in the coming months and years. So for the Finnish audience, we have a webinar about forestry related opportunities in North America in this Wednesday. And then for the Canadian and Finnish audience, we will host an innovation exchange webinar in February or March. We haven't decided a date yet. And a bunch of interesting companies will give a presentation what's new in the forestry industry. So stay tuned. The Finnish Forest Strategy webinar will be held in March. In fall, Forest Joensuu will be attending Demo International in Ottawa. In Finland, in November, Forest Joensuu will host Forest and Photonics event, and that event is in-person event. In 2025, so next year, Forest Joensuu will host a big event called Forest Joensuu 2025. So stay tuned on that. More information will be sent in the coming months. So that's all from my end. Feel free to reach out to me if I can be any help here in BC, or alternatively, you can be in touch directly with Jarno Hämäläinen, who is our key account and project manager for this BC project. So both our contact details are listed on this slide, and that's all for now. Thank you.